Hello everyone, welcome to the YouTube channel. So in this session, we are going to discuss about the SHM questions from the topic electrostatic force or Coulomb force. ಸೊ ಈ ಒಂದು ಟಾಪಿಕ್ ಮೇಲೆ ನಿಮಗೆ ಯೂಶುವಲಿ ನೀಟ್ ಆ್ಯಂಡ್ ಜೆ ಇಯಲ್ಲಿ ಕ್ವಶನ್ಸ್ ಕೇಳುವಂಥ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಕಂಪೇರ್ ಟು ಕೆ ಸಿ ಟಿ ಆ್ಯಂಡ್ ಕಾಮೆಂಟ್ಗೆ. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದಿಸ್. ಇನ್ ದಿಸ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಟೂ ಕೇಸಸ್. ಇದ್ರ ಮೇಲೆ ತುಂಬ ಕೇಸಸ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ ಡಿಫ್ರೆಂಟ್ ಚಾಪ್ಟರ್ಸಲ್ಲಿ. ಸೊ ಈ ಕೇಸಲ್ಲಿ ನಾನು SHM ಅನ್ನು ಉಪಯೋಗಿಸ್ಕೊಂಡು ಕೂಲಂಬ್ ಫೋರ್ಸಲ್ಲಿ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅಂತ ಒಂದು ಎರಡು ಸಿಚುವೇಶನ್ಸ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ಸೊ ಬಿಫೋರ್ ಗೋಯಿಂಗ್ ಟು ದ್ಯಾಟ್ ಲೆಟ್ ಮಿ ರಿವೈಸ್ ಯು ಒನ್ ಸ್ಮಾಲ್ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ಇಫ್ ಐ ಹ್ಯಾವ್ a spring, massless spring attached to a mass here. ಇದೊಂದು ಮಾಸ್ಗೆ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ದಾರೆ ಅನ್ಕೊಳ್ಳೋಣ. ಆಫ್ ಮಾಸ್ m. ಸೊ ಈ ಒಂದು ಮಾಸನ್ನ ಪುಲ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಅಂಡ್ ಆಸಿಲೇಟ್. ಎಸ್ ಆರ್ ನೋ? ಇಫ್ ಐ ಪುಷ್ ದಿಸ್ ವಿತ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್, the restoring force pull it backwards. So sudden ಆಗಿ ಬಿಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, it will push and pull. So to and fro motion ಇರುತ್ತೆ. SHM ಅನ್ನು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಿ. This restoring force is given by what? Restoring force is given by minus k into x, displacement that we give. So negative sign indicates that restoring force is opposite to the displacement. Magnitude ತಗೊಂಡ್ರೆ kx ಅಂತ ಬರುತ್ತೆ. ಏನಪ್ಪಾ ಇದು k ಅಂತಂದ್ರೆ ಇದು ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ದಿಸ್ ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೆ ಈಸ್ ಗಿವೆನ್ ಬೈ ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಎಂ. ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಎಂ ಅಥವಾ ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕೆ ಬೈ ಎಂ ಆಗುತ್ತೆ, ಆರ್ ಒಮೆಗಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಕೆ ಬೈ ಎಂ. ಅಂಡ್ ಒನ್ ಮೋರ್ ಕೇಸ್, ಒಮೆಗಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 2 ಬೈ ಟಿ. ಒಮೆಗಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 2 ಬೈ ಟಿ. ಟಿ is called time period of oscillation. Okay, this is angular frequency. So 2 pi by t, frequency is given by 1 by t, angular frequency is given by 2 pi by t. So what is the time period of oscillation? Here t is given by 2 pi by omega. So omega andre eno, square root of k by m. So 2 pi, let me write that here, t is equal to 2 pi, omega is k by m, reciprocal of it is m by k. So this you have studied in first PUC. Yes or no? If not, no problem, you can copy this. Clear? This is the basics. Now I will consider the electrostatic force situation here. Let's consider three charges. Here one charge is there. Here there is one charge. This charge is Q1. This charge is Q2. ಅಥವಾ ನೀವೇನು ಮಾಡೋದು, ಇಲ್ಲೊಂದು ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಅಂತ ತಗೊಂಡು, ಸೊ ಎನಿವೇರ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಚಾರ್ಜಸ್ ಲೆಟ್ಸ್ ಕನ್ಸಿಡರ್ ದೇರ್ ಇಸ್ ಎ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಪಾಯಿಂಟ್. ಈ ಒಂದು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂದು ಆಪೋಸಿಟ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ದಿಸ್ ವಿಲ್ ಬಿ ಆಪೋಸಿಟ್ ಚಾರ್ಜ್, ಇಲ್ಲಾಂದ್ರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಚೀವ್ ಮಾಡೋದು ತುಂಬ ಕಷ್ಟ. ಸೊ ದಿಸ್ ಈಸ್ ಫಿಕ್ಸ್ಡ್, ದಿಸ್ ಚಾರ್ಜ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್, ಅದು ಮೂವ್ ಆಗೋದಿಲ್ಲ. ದಿಸ್ ಚಾರ್ಜ್ ಇಸ್ ನಾಟ್ ಮೂವಿಂಗ್, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಫಿಕ್ಸ್ಡ್, ಇಟ್ ಇಸ್ ನಾಟ್ ಮೂವಿಂಗ್. So this is movable. Because of net force acting on this charge, it is at rest. What I will do is, I will pull this charge in this direction and leave. What happens? It oscillates. Just like if I pull this mass and leave, it oscillates because of spring force. Here we have the electrostatic force which is invisible. Electric field is not visible, right? So if I pull this, so this one and this one, so interact each other. So this charge, if you pull and leave, if I pull it to some distance that is x, after that it oscillates because there will be restoring force acting on it. That restoring force is given by what? K into x. The magnitude of restoring force is given by K into x. I need to find out that K value here by using Coulomb force. Let's consider the total distance is r. Here to here is r. Here to here is r. You can take it as a also. A, x, r, y, whatever you want. I will take it as r. What is the force between these two when it has replaced? So this charge is here now. What is the force? Force between q and capital Q, let me write it as F1. That is equal to force between these two is F1. K, Q, capital Q by this distance r minus x whole square, r minus x whole square. Yes or no? Next, F2. This displacement should be very small. F2 K Q into capital Q divided by this distance now. R plus X whole square. But you got the two forces acting on this charge now. Same charge is pulled here. Same charge from here to here it is pulled. Okay. So what is the forces acting on this? F1 due to this one, F2 due to this one. If I leave it oscillates. So because of net force, let's calculate the net force here. Okay. So net force is given by F1 minus F2. This will be bigger because distance is less, this will be more. Denominator is less, numerator will be more. So F is equal to, what is F1? K Q capital Q by R minus X whole square minus this one K Q capital Q by R plus X whole square. Correct? Yes or no? Yes. F is equal to K Q capital Q into, so cross multiplication ಮಾಡಬಹುದು, ಅದಕ್ಕೆ ಮುಂಚೆ simplify, you can do faster or let me do it in one more step like this. So shall I write from here to save some space? So F is equal to K Q Q R plus X whole square this side minus R minus X whole square divided by R minus X into R plus X. R plus X square square, okay, whole square you can do. You can do whole square. Yes sir? Into is there, whole square you can do. Now just simplify this. K Q capital Q, K Q capital Q into A plus B whole square formula, A square plus B square plus 2AB minus A square plus B square, A square minus is there, within the bracket if you put, you will be having plus R square X square, plus becomes minus, minus becomes plus, plus 2RX divided by A plus B into A minus B, A square minus B square whole square. Correct now? R square get cancelled, X square get cancelled. So we are having F is equal to K Q capital Q 4RX divided by R square minus X square whole square. So this is one thing. What is K here? 1 by 4 pi epsilon. Before that, what I will do, I will equate. For example, if X value is very small, this displacement X value is, let's consider 1 micrometer. 1 micrometer square is 10 to the power minus 6 whole square is 10 to the power minus 12. So X value is very small. If in case, if R is so much greater than X, what you can do? X square can be neglected. Neglect X square. X will be 10 to the power minus 6, but X square is smaller, and for that there is one more square. That's why in the denominator X square can be neglected. So this gives you a new force, that is F is equal to K is 1 over 4 pi epsilon naught QQ 4RX divided by X is 0, R square whole square is R power 4. 1 R get cancelled. Here 4 get cancelled. So therefore the force is given by F is equal to Q capital Q X divided by pi epsilon naught R power 3. 1 R get cancelled. So into X we can write. So if you consider this is equation number 2 and this is equation number 1. Look at this. In place of F is there. In place of X we have X. In place of K what do we have? This one. So therefore in place of K we have, what is that term? q divided by pi epsilon naught into pi epsilon naught into r cube. That we can substitute here to find out omega. Omega is equal to square root of k by m. So that is equal to, what is that? K is q divided by pi epsilon naught r cube into m. M is there. Similarly, you can calculate time period also. What is time period? 2 pi square root of m by k. So t is equal to 2 pi square root of m divided by k value is this q divided by pi epsilon naught r cube. Take 2 pi inside, 2 to the 4, pi square into pi cube, m epsilon naught r cube divided by q into capital Q. This is very important for JEE as well as Neet. Artha agidya? Okay, if you want me to explain it in Kannada also, please text in the comment section. I will try to explain in detail in Kannada also if it is required. ಇಲ್ಲ ಸರ್ ನನಗೆ ಇಂಗ್ಲೀಷಲ್ಲಿ ಹೇಳಿದ್ರು ಸಹ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತಂದರೆ, ಸೊ ವಿಲ್ ಕಂಟಿನ್ಯೂ ವಿತ್ ಇಂಗ್ಲೀಷ್. ಸೊ ಸೇಮ್ ಥಿಂಗ್ ಕ್ಯಾನ್ ಬಿ ಸ್ಟಡಿಡ್ ಇನ್ ಅದರ್ ವೇಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಪುಲ್ಲಿಂಗ್ ಹಾರಿಜಾಂಟಲಿ, ವರ್ಟಿಕಲ್ ಆಗಿ ಏನಾದರೂ ಪುಷ್ ಮಾಡಿದ್ರೆ ಚಾರ್ಜನ್ನು ಏನಾಗುತ್ತೆ? ಓಕೆ, ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ದಟ್ ನಾವು. ಒಮೆಗಾ ಆ್ಯಂಡ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಆಫ್ ಎ ಸಿಸ್ಟಮ್ ಇಷ್ಟ. Now I will take it to the next case where we have two charges, capital Q and capital Q, separated by some distance. Let me consider from here to here it is R, from here to here it is R. Let's consider there is a charge here at its center. ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಇದೆ, ಅದನ್ನ ಇಲ್ಲಿ ಪುಲ್ ಮಾಡಿದ್ದೀನಿ. Okay. So here there is a charge. As of now, in the diagram I will show bit more displacement, but in theoretical, in practical actually this displacement will be very less. X value will be very less in micrometer or even less than that. Ilon charge ide. If these two are opposite, ಏನಾಗುತ್ತೆ? Attractive force ಆಗುತ್ತಲ್ವಾ? So this distance is, let's consider x. So let's consider there is a force along this direction which attracts in this direction, F. So let's consider this is theta. So there is one more force in this direction, that is also F. So what is the force in this direction? Resultant force, F resultant. So F along resultant is F cos theta. F resultant is given by illi theta ideyala. So this will be F cos theta. Perpendicular is F sin theta, right? So F sin theta, and this side also F is there, that is along vertical plus F sin theta. So resultant force ಏನಾಯಿತು? F sin theta plus F sin theta. If you pull the charge and leave, it oscillates like this. So if you take the resultant of force horizontally, you will get F cos theta. ವರ್ಟಿಕಲಿ ಎಫ್ ಸೈನ್ ಥೀಟಾ. ಇಲ್ಲೇನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಹಾರಿಜಾಂಟಲ್ ಫೋರ್ಸು ಇಲ್ಲೇನಿದೆ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಮತ್ತು ಈ ಕಡೆ ಇರುವಂಥ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಕ್ಯಾನ್ಸಲ್ ಆಗಿರುತ್ತೆ. ದಿ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ದ ಫೋರ್ಸಸ್ ಆನ್ ಇದರ್ ಸೈಡ್ ದೇ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ಓನ್ಲಿ ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ಫೋರ್ಸಸ್. ಓಕೆ, ನೌ ಎಫ್ ರಿಸಲ್ಟೆಂಟ್ is given by, let me write here only, 2 times F cos theta, F sin theta. So 2 times, what is F? K Q1 into Q2 divided by, this distance is how much? This is R. This distance is how much? So for small displacement, this distance and this distance will be same. So we'll take R square only. Okay, you can write Pythagoras theorem, square root of R square plus S square power 1 by 2. But as of now, if theta is very small, if theta is small, Okay, sin theta is equal to what? Tan theta. So adjacent and hypotenuse values will be almost same. So I'll write it directly. And sin theta is given by opposite by hypotenuse. The hypotenuse is r again. Opposite by hypotenuse. Hypotenuse is equal to r for smaller displacements. So I can write like that. So that is 2k qq divided by r cube into x. This can be equated to kx, force constant and displacement, which comes under SRM. So in place of x we have x. In place of k, what do we have? K is equal to 2q k. K is 1 by 4 pi epsilon. This k, let's consider this k dash. This k is 1 by 4 pi epsilon naught into r cube. So this is where you get confused. If you use the same term for different physical quantities, you will get confused. K is 1 by 4 pi epsilon naught, 2 qq divided by r cube. Okay, so this is force constant that we can substitute in the omega. Omega is equal to square root of k by m. Square root of k is what? 2 or k dash you can take. Q divided by m is as it is divided by 4 pi epsilon naught into r cube. So if you want to cancel, you can cancel 2 also. 2 2s are. Okay, so this is omega, that is equal to square root of q divided by 2 m pi epsilon naught into r cube. So what about time period of oscillation? How much time it takes for one complete oscillation? Time period is given by t is equal to 2 pi square root of k by m, right now, k by m. That is equal to 2 pi square root of k value is this, divided by m. Now, just a minute. This is m by k. So, reciprocal of this, that is 2 pi m epsilon naught r cube divided by q into q. You can take 2 pi inside. 2 to the 4, 4 to the 8. 8 pi square into pi cube into m epsilon naught r cube divided by q into q. Correct now? Outside 2 is there. Inside if you take 2 to the 4, 4 to the 8, pi square inside into pi cube. M epsilon r cube divided by q as it is. This is time period of oscillation. Okay. So this is how you can apply what is this Coulomb force in SHM in electrostatics. Even few more are there. We'll discuss about them in the coming videos. So try to share. If you feel this content is useful, please try to share it to as many as possible students, so that I can get motivated and I can make more valuable and interesting videos like this. Keep supporting. Thank you so much.